Hello, Flat Earth researchers, debaters and debunkers. I just would like to give you a short preview of some of the material that's going into the second in a series of videos titled Breaking the Ball. And I'd like to just try and illustrate here how the same rules apply whether you are circumnavigating a globe or the flat Earth when it comes to talking about the cardinal directions, north, south, east and west, depending on your location, and also the heading of the sun as it rises and sets. So here we have the sun, the small sun, above the flat Earth, above Africa, and doing circles above the equator in a westerly direction. So we can see, just as with the globe, you would have to follow a circle to go around the globe in an easterly or westerly direction. And the same thing applies here above the flat Earth, or even on the flat Earth. If you were travelling around it or circumnavigating it, you would follow that circle around the equator, just as you would on the ball. Now, of course, if we were standing directly beneath the sun in Africa, it would be midday for us. Now, of course, somewhere like Stockholm up in the northern hemisphere and parts of South Africa are on the same time zone. So it would also be midday in South Africa and in Stockholm with the sun there. But of course, if we were looking at the sun from Stockholm, we are quite far away from it. And so the sun wouldn't be as high in the sky. And the closer we get to the sun as we travel south, the higher the sun will be in the sky at midday. But until we are directly beneath the sun on the equator, we won't have the sun go directly over our heads. So of course, if we were in South Africa, we are still fairly near the equator, so the sun would be fairly high in the sky, but from there we would have to look north to see the sun. But our heads would be tilted upwards about maybe 70 to 80 degrees. Now, if we add more compass points in different locations around the world, in Australia and South America there, you can see that the north is always facing the center of the globe or the flat Earth. It's the same with both models. And of course, your east and west are perpendicular to that north. So wherever you go on the globe or the flat Earth, your east and west and south is going to change as you move around the globe, with your north pointing to the center, east and west perpendicular to that. So if we now just go back to looking at the sun rise and set from our viewing point in Stockholm, we've got north facing the center, the east and west off to the right. Now you can see the purple arrows are pointing towards where the sun will rise, and that's called the sunrise heading, and that is going to be in the southeast from our local compass points. And you'll see that when it's midday for the people in Stockholm, they have to look south towards the sun. It won't be going directly over their heads, which is another firm indicator that the premise that we are a small, tiny dot compared to this massive sun just cannot be correct. Otherwise, I think you might agree that we would always have to look east or west to see the sun rise, the massive sun rise on our tiny Earth, no matter where we were on it. Anyway, we can see the arrows pointing to the southeast for the sunrise and the southwest for the sunset from Stockholm. And the dotted purple line represents the arcing of the sun that we would see as it appears to rise above the horizon as it essentially gets closer to us on its circular path. When it's directly south is when it's at its closest point to us in Stockholm, so it will actually appear higher in the sky, but of course it will be nowhere near the 80 or 90 degrees that it would be if it was directly above our heads when looking from the equator. And we can see here that the same thing would apply, but in reverse, if we were looking at the sun traveling across the sky from, say, South America, we would have to look north towards the sun, but it would still be very high in the sky for us. Our heads would be tilted fairly high upwards, almost to the 90 degrees, but not quite. So we would see the sun rise at a heading northeast because we are below the equator, and then it would go and set in the northwest. You can see from those blue arrows there. And of course, with the dotted line, this is the arc we would see as you see the orange circle at its closest point to our viewing location. This is the corresponding peak of the dotted lines. With the sun being at its closest point to us, it will also appear much higher in the sky. Okay, there you go. That's just a part of what's going to be included in the second part of Breaking the Ball series of videos. Hope this has been helpful and clearly illustrates that no matter whether you are circumnavigating the globe or the flat Earth, the same rules apply. Nothing changes. Thank you.